Get it now. I love ironing. Anybody likes ironing shirts? Anybody? 4 of us, we need to get together and create some sort of a group. This is great. Like we can speak for hours about ironing. I think there is a lot of value in that. And if you're watching now online, you feel like you belong to this group, please let me know, because there is some value in that. Now, first of all, I come in peace to you today. I come with chocolate. Right. Anybody wants a chocolate? Just to start out? I can barely see anybody. Anybody in the back, maybe? Don't be shy. I can throw things, I was told. Okay, one more, maybe? In the back, all the way in the back somewhere. Wow, impossible. I mean, do we have insurance here? Oh, right, here or there. Not bad, huh? I tried. Okay, one more, and then we can start, I think. I mean, maybe this. Oh. That'll be too much. Anybody? All right. Here we go. I have no idea if I hit anybody or not, but this is kind of how it works. All right. Well, I come in peace. I come in peace because over the last couple of years now, we've been kind of dabbling and trying to find things around performance. And some things were really, really weird. Some of them are really, really strange. And some of them are maybe just everything you ever not wanted to see, right? So you might see a couple of really strange hacks around, but I'm going to try my best to, give you some insight about what we can do today to really boost web performance at this point. And we need to really think first maybe about the state of things, right? Kind of where is it, or where are we actually at this point? So I need to remove this because I can't see anything. And we need to go back in time. Anybody remembers this? Oh, I got more applause than for the chocolate. How does that work? Anybody finished it when you're growing up? I never managed to finish it. So I spent so much time just trying to figure out how to get it done. And I would go from one place to the next in the kind of YouTube channels, like the walkthroughs, and it was incredible. Anybody remembers this maybe by any chance? Oh, one person. Are you the one who created it? No. Oh, this was the time when I got on the web. Do you remember the first moment when you experienced the internet? Anybody? Maybe. That was incredible. This site is today 24 years old. This website was designed and created and published in 1998. Look at how performant it is, because it's a video, right? But this is incredible, right? You could do this on the web in 1998. I was so excited when I saw this, and I thought, wow, this is unbelievable. But please do not forget that this was the time when this was a thing. Ooh, anybody remember modems and stuff? Incredible, really, really nice, right? So I don't know if you can hear it. Yeah, it's a modem carrier. This brings back memories, right? And look at us today, in 2022, almost 2023, just a couple of years later, we are here, right? We are loading and loading and loading and hoping for the best and keep clicking and keep clicking around just to make sure that things are working. And then eventually, maybe we're just giving up because it's just too much. I mean, we are creating incredible things. Like, look at this thing. Right? Beautiful. It's like a mini map of Tokyo where you can walk around Tokyo, also observe the different corners of Tokyo. But even on my M1 machine, it's so slow. I can barely use it. Right? This is just really, really, really difficult to use. So when we start thinking about those things, not to mention these beauties, this is not a performance issue. This is the world issue, right? We don't get this anymore, to be honest, because we don't see captures anymore, do we? No, they have transformed, they have evolved, they have matured into this. Or is it maybe just me, but sometimes questioning my life choices? Like this part, is it still a crosswalk? Is anybody like that? Yes? What an incredible world we ended up with. Not to mention those things. I always wake up and I hope, maybe today I'm going to get another game. Like pick the right password, right? Oh, those things are just really, really, really getting on my nerves all the time. But over the time, we ended up here, right? This is a quite complicated world in which we're living. We have to think about how we render things. We kind of learned very quickly that actually, we kind of don't want to be on the SSR side of things. We kind of want to be on the CSR side of things, client-side rendering, but that's not going to be performant enough. So we better stay somewhere in between. And we kind of added the static component to it, and at some point we said, maybe we don't want to hydrate everything at once, we want to partially hydrate, and on top of that we also get to all these metrics that we have in front of us, right? It's like, what do we choose, how do we optimize, core web vitals and all these things, and in the end you just want to write some code, right? You just want to write a piece of code, but then all the frameworks and everything coming our way, and off we go. We need to do some stuff around it to optimize. So when we start looking around, we'll find out that, first of all, one thing we know for sure, a mobile has become a spectrum, so we have many, many very different devices, and have very strange hobbies at times, and one of them is going to different markets on Amazon and see what are the most popular devices that are being bought this month. These are the ones from Amazon UK, as of now, as of today actually. Anybody got Nokia 10105? Maybe not, that's a little bit unlikely, but maybe anybody got, let's say, I don't know, maybe this one, Galaxy A13? Awesome, but we are maybe not the target audience, but these are the most popular, best-selling phones in the UK as of today. And as you keep going down, you'll find a lot of cheap phones, like ridiculously cheap phones. Like, for example, I don't know, this one. Anybody has a Doro 2404? That's a nice name for a phone, right? So there are reasons why people buy those phones. They're cheap. They still might have an Android running, right? But if you go to other countries, you'll find very, very different things. In India, it's barely possible to find any phone that's going to be billed above $100. So the one that you see in the left upper corner, Redmi 10A, this costs like $108. So we shouldn't probably be expecting a really, really great performance of it. But then you go to Russia. Like, oh, I was really surprised for a moment, right? And this is all over the place. Like, these are the most popular devices being bought as of today. And so when we compare these phones side by side, what we find out is that there is a significant difference in their performance. I mean, significant to the point, actually, that there is a significant performance inequality gap. If you buy a phone today, like let's say a mid-tier Android device, around $300, that's a good budget to have. They have today the single-core performance of a 2014 iPhone and the multi-core performance, a cooler one, of a 2015 iPhone. And that's like, what, 7 years old now, right? So typically, what we're looking at are pretty bad phones. So which is why typically when we're kind of testing for performance, this is going to be the state of things. We're going to test on Android devices at least 1 year old and maybe around $200 as a pricing point, right? Now, fortunately, we've got kind of really better in the world of JavaScript over the years. I mean, this is remarkable, all the things that we have in front of us today. I mean, I don't even know where to start, but we tend to focus somehow on those two. Right? We have React and Vue, maybe React and Next.js, and maybe Vue.js and Nuxt, right? But then we also have Svelte, and we also have Preact, but then we also have Jamstack, and now we also have Remix. So where do we even start now? Now, fortunately, there is a lot of work being done in many of the frameworks to optimize them out of the box. This is called the Aurora project at Chrome and Google's team, where we try to make sure that every single framework is actually optimized out of the box. That's great news. That's fantastic to see. But where is this? I mean, my entire life is jQuery. Sorry about that, right? I'm spending most of my time working with governments, working with enterprise applications. There is no React. We'd be happy if we could upgrade to a new version of jQuery. That'd be nice, right? Anybody else stuck in jQuery world? Nobody wants to admit that. I get that. We have a party coming up. You don't want to be that person, right? jQuery person. But my world is jQuery. So if you're watching this later online, send me a message. We can be jQuery friends. Or not. I don't know, right? But what's really surprising to me, that's a little bit sad, really. We have all these conversations about all the fancy things we can do today. And that's great. We need these conversations. But I would love to see just a really good blog post about how to move from jQuery to something else in an enterprise environment. Because when we look around the adoption of top JavaScript frameworks, jQuery makes for 83% in 2020. More than that, in 2021 it grew by 1%. Right? And jQuery people, we are here, we are still here, right? 84, but this year we experienced something strange. jQuery fell by 3%. It's not too much, it's not too bad, we're still here, right? But to 81% still dominating as of today, right? And so if you're thinking jQuery is dead, it's dying, but it's definitely not dead, right? But you know what's really interesting in testing, when I do all this work with enterprise clients and all, jQuery always performs better. So it doesn't matter what you look at. Like if you think, React, Angular, Vue, even Svelte, or even Preact, right? Sometimes jQuery would be performing better. It doesn't mean that we need jQuery necessarily. I would love to remove it and just use vanilla JavaScript instead, of course, right? But it's, it's working. It's performing fairly well. In fact, if we actually start looking around, we'll find out that just in terms of main thread processing time, jQuery outperforms everything, right? So great news for jQuery, not for us though, right? Because I don't want to be in the world of jQuery, right? So we started thinking about how can we actually make things a bit better. And so a few approaches came up, right? One of them, we have maybe heard of Hotwire, we maybe have heard of HTMX, we maybe also heard of Quick. And especially in terms of Quick, anybody heard of Quick? Yes, a few people, somebody, Quick team here, maybe? No, I'm kidding. Quick is great. So I really highly encourage you to look into this because this tweet really raised my expectations and also just my interest. Because Mishko has tweeted, hydration is a horrible workaround because web frameworks don't embrace how browsers actually work. Yet somehow we turned it into a virtue. Hydration is a hack to recover the app and framework state by eagerly executing the app code in the browser. This is why your app is slow. So when he's speaking about this, he's speaking about hydration overhead. Because we obviously need to know what event handlers we need and where they need to be attached. But typically, in hydration, we do so by downloading, executing components in HTML, kind of rebuilding the app. So this is what our typical, our typical process would look like. We get HTML, download all the JavaScript, parse and execute it, then recover state and bind listeners. So the idea is, well, because typically when we build an application, the framework is kind of trying to rebuild the information that the server already gathered via static site rendering or SSG. And that's kind of really expensive to gather it from the server. So what if the server could send it to the client instead of rebuilding it on the client? And this is the concept of resumability, right? Where the idea is, well, we actually do it slightly differently. We have the components just in the way that we usually would write them. Oh, I have a monitor here. That's helpful. But we load it differently, right? Where we just plug in enough information for browser to understand what they actually need to execute, let's say, something when they need to attach some event handlers, right? So that's actually pretty neat. And in fact, when you think about this, the difference is, right, maybe I can just jump this one. The difference is with hydration, we eagerly fetch, right, and run the code to register event handlers. But with resumability, we wait for user to trigger an event and then lazily create a handler to process it. So this is actually quite neat because this brought us to this really new thinking. Instead of having this just everything happening at once, we break it down into very, very small things. And essentially, you can think about your React application as a suite of small React applications, but many of those. And you would basically go ahead and say, well, I'm just going to plug in this part and I'm going to hydrate only that. So we're getting very, very granular in terms of how and when we execute things, right? So this is actually quite neat to see. And obviously, the same things we see also in things like, let's say, suspense, right? Because whenever we look in there, there are always these issues that we have with hydration. And that's, we need to fetch everything before we can show anything. We need to load everything before we can hydrate anything. And we need to hydrate everything before we can interact with anything, right? And if we actually go ahead and say, we have this application, it contains a couple of functions here, we need to wait for the last one to finish before we actually go ahead and proceed, right? And can render something. So instead of having one application doing everything, we have a lot of applications doing just their thing, right? I mean, we still need to wait for suspense to kind of to be able to use all of it, right? And it's still a work in progress. But this actually is really, really promising. What's really interesting to me, though, is just how difficult the work of a developer has become. Because when I work with these projects, right, in enterprise, one thing that's actually typical and very common is this notion of adaptive serving, where we don't just build components. We change components based on network conditions, based on, of course, the screen, based on available memory, based on available market or where it's actually going to go. So it's typically a design system or a system that you're creating, a code base, will include all the different states, plus dark mode stuff, plus if you think about forced contrast, forced colors, it kind of really breaks up and actually makes things much more complex. But we of course think that things are going to be resolved on their own sometimes. And it's interesting because when we start looking around, we'll find that, for example, 5G has broke it. So 5G is coming, and at this point the adoption is really remarkable. It's already at 25%, well, almost 25%, and it's going to grow very quickly. And we're expecting incredible speeds as well. You probably are, or maybe some of you already are using 5G at this point. But what we get is, we can download one episode of Game of Thrones within 90 seconds in 4K, or 35 seconds in full HD, or fetch the entire season in 15 minutes. That's incredible, right? So that's really impressive to see. So at the same time, though, we need to be a bit careful. Because one thing that we learned as well is that mobile can be faster than Wi-Fi. Wi-Fi can be faster than mobile, but we cannot predict it. It really depends on the country where you are. Because, for example, in Hong Kong and in Thailand, Wi-Fi is indeed much faster. But if you look into Lebanon, for example, if you look at many parts of Europe, mobile is going to be faster than Wi-Fi. So we cannot reliably say, well, if somebody is using a Wi-Fi connection, then we can assure that we are going to send them a full experience, and maybe for the mobile, a light experience. This is not going to work. It's not that straightforward. And on top of that, we get this another thing coming up, which I was really surprised about. So in many of the projects now, and now I'm working with the European Parliament at this point, there is a question that came up about how we're going to secure the performance in terms of environmental impact. And specifically, how can we reduce the amount of stuff that we're sending to the browser to ensure that we're environmentally friendly? And because if you think about big companies that always promote the idea of sustainability and environment, right? Very much the website, the applications that we're building also need to respect that as well and need to show this too. So this is one of the documents that we actually ended up creating for the European Parliament just to highlight everything we're doing for environmental friendly design and development. This is a huge document affecting everything from text and fonts and images and videos and everything else. Like one simple example of that would be, when you think about a video player, typically a video player would have SD, HD, maybe 2K, maybe 4K, right? But why do we never see actually something like audio only in a video player? Many people are going to watch it almost in parallel on another screen, maybe never actually watch the screen, maybe they don't need to waste so much bandwidth. So these are the conversations that I actually keep having, right? And this brings me to this idea of system KPIs, and I don't want to go into too much detail on that, right? But this is one of the first things that we are creating before writing, before designing, before building anything. And this is in front of everyone, right? This has become a very important step in the development process before we even get into debugging or performance stuff. Why? Well, because there are so many things we cannot control. These are the things that we can control. Why? Well, for example, if you think about web performance, we should not be thinking just about the performance of our application. We need to put it in the right context. What is it? Well, we need to think about the users, what kind of browser extensions are they using, and because they're not going to use our site or our application on a clean machine, on a clean browser, right? So we need to think about what is more realistic. And if you start kind of just diving down into this, I was so amazed. Chrome extensions have an incredible impact on performance of our applications. And we cannot control it, right? We don't know what browser extensions people are going to use, but we need to be prepared of what's going to come up. Because, for example, if you have a lot of images, they surely should be expecting Dark Reader to raise the alarm. It will take, with Dark Reader, for example, on apple.com, it takes 3 full seconds of blocking rendering, right, just to transform all the images in the right way. And this is something, again, that happens usually or typically before your application is going to load. Because if you actually start looking into what it looks like in the profile, right, in browser profile, this is what is going to happen. So you will have your website code running, but there is also X and LastPass and Skype and whatever else. So this is going to be delayed heavily by those Chrome extensions. So one tool I can only recommend to you is Chrome extensions performance lookup. So if you know what extensions in your industry, the users in your industry are using, you can then predict much more granularly, okay, what experience they're going to have. Which is why typically, again, in terms of performance, to optimize things, before we even start debugging, before we even start optimizing, right, we always think about creating profiles, different profiles, depending on the task that we're trying to solve. One of them will be a happy customer profile. That's a happy customer that never exists, right? That's a person who has no extensions, clean machine, everything is fast, the screen is beautiful, everything is perfect in the world, right? But this is the baseline that we cannot rely on, but we need to know where we are at best. But on the other hand, we also need to think about the unhappy customer. That's a customer who has at least 10 most popular extensions in the industry. They are not running on a good machine. They're not running on a good mobile device. And this is much more realistic experience, right? And on top of that, we have some performance profile for performance issues, debugging issues, and accessibility issues as well. This is probably one of the first things that we're going to do, right? But then, jQuery people, hold tight. What about this? We just, buried our friend over there, right? Is it still kicking? Did you check? Right? I don't know, maybe it did. Because in my world, it's still a thing, hopefully not for long, but it's not like it's gone, right? I mean, it's mostly gone, but it hasn't disappeared entirely. However, I have to say, and I was so happy to experience this moment while being alive, I didn't think that this is going to happen. I met one person, right, who was speaking to other developer, and they're like, do you know this thing that everybody's talking about? Like, what thing? This IE thing? What is IE thing? I never met IE. What is it? Like, this is it, right? My world has changed altogether. Somebody doesn't know what Internet Explorer is. Does anybody not know what Internet Explorer is? Maybe a few more years. Maybe just a few more years, right? But luckily, it's kind of dying, so that's a good thing. We also tend to think that, Safari is dead. No, it's not dead. Sorry if you're working for Safari. That Safari is like, this new kid around the block that doesn't play along with everybody else. Well, actually, Safari is really, really great. If you look actually in what has been done in Safari 16 beta, it's unbelievable. Like, the updates are really moving along, and it's incredible to see incredible progress done there. So we can't say that Safari is doing a bad job there, right? So what do we do with all of this? Well, let's take a look at some techniques that we actually have discovered. And specifically, of course, looking into these beauties. Right? We've seen them before. I don't have to explain that. One thing, however, that is really important, and that's a conversation I keep having all the time. So what should we pay attention to? Lighthouse score or Core Web Vitals, or both? Right? Because even if you're, let's say, 50 on Lighthouse, you could still pass the Web Vitals scores. Or if you, again, let's say, pass the Core Web Vitals, it doesn't necessarily mean that you're going to be someone within 100 on Lighthouse, right? So as it turns out, there is indeed a strong correlation between the two, but almost half of all pages that scored 100 on Lighthouse did not meet the recommended Core Web Vitals values, right? So that's actually quite important to keep in mind. So what do we do then to improve things? Well, basically, I want to show you a few things that we ended up creating or doing here for the Smashing Mac site, just because we ended up with this beautiful chart. Can you feel how much pain I was going through in this fight against Core Web Vitals? Anybody? Oh, wow, this was really, really hard, right? Because in the beginning, we were all red. And then it wasn't a good experience. And then we went all Ember. And I was celebrating for one evening, right? Ember, only Ember. But then kind of going back and forth until we got into the green zone, that took a lot of time. So let's see what we can do there. And let's start with something very, very simple, like images. What can be done with images? Images are easy, right? Well, images can be easy, except if you're working on a project that has a lot of them. So this is Tijuana Flats. Tijuana Flats is a chain of Mexican restaurants in the US. And this is what they look like when you enter them, right? And these are the people in the restaurant ordering. Right? These are really, really big walls. So every now and again, a few months or so, graffiti artists would come in and repaint and continue and unfold the story that they started initially, right? So obviously, this visual presence is very important to them. And that visual presence has to be reflected everywhere, including the menu, as it does, that looks great, but this also should work for their website. So meet their website, right? It has a couple of images, right, I would say. Now think for a second how you would make it responsive and fast. That's quite a website, I would say, right? So anybody would say, let's SVG all of it. Anybody? Please not. Let's not SVG all of it. That would be a little bit too much. Right? WebP, everything. Oh, this is probably going to be a little bit scary as well. So how would we deal in a situation when we just have a lot of images to deal with? Well, there are a few things. Like one simple technique we can always use is to break things depending on dependencies or responsibilities. So if you have something simple like this, where you have maybe a beer can and you have some drop shadow in the back, right? Typically what we would do, and this is what we would do a lot on this site, we'll break things into layers. And we'll put one layer on top of the other layer, on top of the other layer, up to 4, 5, or 6 layers if it needs to be. And that typically means, again, we will have an SVG file. That would be a container for our bitmap images and maybe other SVGs inside as well. And then once we do, we could put a mask on top of one image on the other, and then we're actually going to plug it in like this. Not too fancy, nothing fancy going on here, right? However, there are many things that we can do actually beyond that. One of them is, well, if you just compare this image against the next image, you might see a little bit of a difference, right? Can you see the difference? Maybe. So there's a bit of blurriness happening in the back. This has saved us around 70 kilobytes on that wide image, right? That's already pretty impressive. That's just a little technique that we can do and use right away. That's pretty cool. But of course, we also have way more techniques. One of them is we need to think about the format we're going to use. And typically, we will be comparing, let's say, JPEG and PNG against WebP, and WebP will be smaller, right? And in fact, WebP is well supported, right? Except for you-know-who, but we don't have to care about it anymore, right? I guess, right? So that's great news. However, and I was really happy, by the way, in 2020, was it in April and May, when WebP got support in Safari, I thought, this is it. My life has come to a point where I can say that all images, like all browsers, support a good image format. But then, next month, I realized I was wrong because, well, AV1 was released. And AV1 is a video codec, and from that arrived AVIF, right? Which is an image format on its own. Anybody using AVIF today? I hope to see a lot of hands. Oh, that's okay. Because actually AVIF is incredible. So if you just compare things side by side, if you look at AVIF against other formats, this is what typically you would get. I say typically a lot today. That's very strange. I never use the word at all. So here we go. This is what it would look like. So we have the original file. Then we have a JPEG. And then we have JPEG with some kernel powers. Kernel is the creator of or one of the contributors to most JPEG. And then we have WebP. And then we have AVIF. And AVIF is much smaller in size, right? Than everything else. And also is really, really good at smoothing those parts that are typically going to look very, very broken in JPEG or in even in WebP. And in fact, it appears that AVIF is even smaller for vector graphic. Now, obviously, AVIF is supposed to be used for bitmap, right? But it's actually working remarkably well pretty much everywhere, except including scalable vector graphics even. But if you compare things side by side, you see that this is what it looks like when you compare the performance of them. Can you spot anything here? Right, at this point, JPEG is still loading. WebP is done now. And eventually, JPEG kicks in, right? And it's going to be done. Right? It just takes more time. So when you compare things side by side here, what you will notice, let me just move over here. What you will notice is, normally, you get AVIF quickly through the network. That's not surprising, but JPEG starts appearing faster. So JPEG appears faster, depending again on the file size, you will get this experience or slightly different. AVIF comes through the network faster. WebP is somewhere in between. It's still not there. It doesn't show the structure that JPEG shows, and AVIF doesn't, it doesn't show the image like AVIF does. And eventually, JPEG gets color, and WebP starts loading, right? And then finally, AVIF is done. WebP is still loading. JPEG looks done, but it isn't, because more and more depth, like colors, are coming in. And then finally, WebP is done. And then finally, JPEG is done. So what should we be choosing, right? Like, most of the time when you think about this, AVIF is going to be a much better choice, right? Well, at least, as long as it's supported in the browser, because obviously we're going to do something like this when we're actually loading those images. You have to check if AVIF is supported. If it isn't, then we're loading by P. If it isn't, we are loading good old JPEG. But one thing we're doing often wrong, I think, is kind of exporting images in the same quality. Because if you think about image quality, let's say for JPEG 90, it doesn't mean that it has to be 90 in WebP or in AVIF. In fact, as it turns out, if you actually expect to get a quality 80 in JPEG, you can actually compress with quality 64 in AVIF, and it's going to make the file even smaller. So you can think about that when exporting images, for example, even if you have a routine doing that. And I thought, okay, this is great news. AVIF has done it. Now we have the winner. But then JPEG XL came up. Has anybody heard or excited about JPEG XL like I am? Well, my jQuery people, you're always excited about things. No, no. JPEG XL is really, really great. This is everything you ever wanted for Christmas, except it's not for Christmas. Right? This is great. This is the best thing ever. It can do everything we ever wanted, I think. Especially here, it supports animation. JPEG XL supports animation. How incredible is that? I'm super excited about that. Then you also get progressive decoding, like we do with JPEG as well. It has alpha transparency. JPEG XL is going to get alpha transparency, so PNG maybe not necessarily needed anymore. And also, if you just compare things side by side, I mean, JPEG XL does wonders. I cannot find out just how would you pronounce this number. That's the support that JPEG XL provides. This is a maximum image dimension you can use, right? And I'm wondering, I can almost hear the whisper in the room, what about browser support? I'm so glad that you asked, right? But do you see the little green flag everywhere? It might be just a matter of months, maybe half a year or so until we actually get it as well. And once we do, this is going to make wonders because it's also backwards compatible. So you can transpile JPEG into JPEG XL, saving on data, but you can also make JPEG XL files work with JPEG. Still, you'll probably need to do something like this now for JPL or JXL, which is going to be the format for it. Right. So this is really exciting new news that I'm very, very looking forward to. Plus, on top of that, of course, we have all those little things that we need to include in our markup, because it's going to be responsive. So obviously, we need to have lazy loading, maybe, or not. And we also need to include the decoding async. Anybody heard of decoding async? Decoding async is a really interesting new feature, not new feature actually, but actually quite helpful because it allows you to asynchronously decode images as well. That just shows us how much granularity at this point we get as access to granularity. Now by default, browsers are going to load text and images at the same time, synchronously. Decoding async tells the browser to defer decoding and prioritize text even although images are not loaded yet. That means that if you compare, again, side by side, asynchronous images and baseline, so you can see that the content is going to appear faster, well, the text is going to appear faster, because the image is not blocking it. You can think about render blocking image at this point, because it's going to hold on and not going to display the text until the image comes through or starts appearing. Now that's actually quite helpful. So adding decoding async is always a good idea. I can also hear the whisper about browser support. It's been around for ages, like forever almost, so there is no reason not to use it. And on top of that, one thing that we often don't know about, I didn't, is that we can actually preload responsive images as well, depending on what image is going to be picked by the browser. So even if we have something like a picture element or source set and sizes, right, we can still add things like image source set and image sizes in the header and say, dear browser, preload one of those that's going to be picked, right? And it's going to pick the one that we actually want to use here. That's pretty neat. So if you want to preload images for your LCP, right, this is something you can do today. And browser support is actually really, really nice here as well. So when it comes to those things, we can go ahead and use it right away as well. That's pretty cool to see. Just one recommendation on a tool. This is a really great one to check and test how well your images are loading, how well they are performing, and if you actually have anything that you need to optimize. It kind of gives you this information about everything and largest contentful paint as well. So you can go ahead and optimize that image if you need to. Right? Okay. Let's move on to web fonts. Oh, now I'm going to get really nervous and really excited too. Because I thought for a moment that we have it resolved. Until I met somebody who was a font loading expert in the company who had to be asked every single decision about font loading, right? And it seems like this is a little bit maybe too much. Maybe it's not quite necessary. Is it really such a big deal? Well, it turns out it can be. Now, if you think about those things, it's really not that hard, right? So we declare the font face, where the font is going to be. We did this 1,000 times now, right? And so we have the font family, we have the font files, right? And we're going to have WOF2 and WOF, and hopefully we don't need to worry too much about ODF at this point. And when a font family name is going to be used in CSS, browsers will match it against all font face rules, download fonts, and then display content. Unfortunately, it has some issues, because normally we would get some font stacks, and this is the one I ended up seeing in the code. This seems a little bit too much, maybe, right? Because we can care about all the different families, right? But we have now some synonyms, so we can use system UI value for font family, but we also have UI serif, UI sans serif, and so on, so we don't have to go all this way to display and define all those font families everywhere. So instead, we do this, which is actually much, much shorter. That's quite nice. So when we're defining CSS, it is in CSS, this is how it's going to work. But we have, for example, this issue. So whenever a font comes in, a web font comes in, you have this switch happening, right? From a fallback font into a web font. That can be quite frustrating and lead to a lot of CLS, like layout shifts. So how are we going to deal with it? Well, actually, when you start thinking about it, one thing we can do is to give browser a little bit of a head start. Now, when we're loading fonts, we will be using something like font display, right? Normally. Where we can adjust the loading behavior for fonts and say, well, you know what, dear font, these are the options that you have, and I'm going to choose one of them. By default, the default behavior is going to be block, which means that the font is not going to be visible for 3 seconds, then we're falling to the fallback, and then eventually when web font comes in, we do the swap. But we have this option, and we can say swap immediately. And then we see the fallback right away, and eventually when web font comes in, then we have the swap. But then we also have fallback, where we give the browser 100 milliseconds to fetch something from the cache, right? And if it does, then we're going to see this, the web content appearing in the web font. And if it doesn't, it falls back to the fallback for 3 seconds. And then eventually, when the web font comes in, it switches. And finally, there is also optional, which is like fallback. But the difference is that it's up to the browser to decide what it wants to do, right? So these are the options that we have. And normally, we'll be maybe using font display fallback, right, for performance purposes. But I would say that we should not stop there, because why should we? I mean, one thing that we learned in our work is that the best thing we can do is to use font loading API. Now, font loading API gives us access to the font face object that would represent font face rules. And so we're defining a font face object, and then in there we can define how web fonts are going to be loaded and also change the behavior based on that. Supported really well. And the idea is, what if we take this idea, this approach that we learned maybe from CSS back in the day about critical CSS, and apply it to fonts? And that's the idea behind critical FOFT, where you actually separate the render in 2 stages. The first, which is going to be everything in the regular, and then the second, which is going to be a full font family, right? So that means basically that once you start rendering, you see everything in a regular at first, and then everything else is going to be all the other bolts and extra bold and italic are going to be loaded asynchronously and then applied, right? But you get a very good first render. It even gets further, because you can also use progressive font enrichment. There is a lot of work being done by Google team, as far as I know, where the idea is just incredible. Why do we need to load fonts anyway? What's the point? Wouldn't it be nice if you could come to a page and say, on this page, I use these characters. For these characters, I'm using this subset. So as you go from one page to the next, to the next, to the next, you kind of match and merge the font files. So by the end, you're going to get the full one, right? And we said, none of it is good enough for us. Let's go for a new acronym. This sounds like a good idea. Let's call it C2SFOFTSW. Critical two-stage fourth render with a service worker, because why not? And the idea is 2 stages, right? In the first, again, we're using the same story, small subset, regular, and we render it quickly, immediately, by inlining the font file directly. But then the rest is coming in asynchronously. And here's the interesting thing that we're doing, right? If we're checking if font loading API is available, and then we group repaints. You know this situation where sometimes you come to a page and you have regular coming in, and then italic comes in, and then bold comes in, and then extra bold comes up, right? It creates all these layout shifts. But what if you actually group them and group these panes? So this is what we're doing here with the font face object, where we say, okay, we have 4 fonts that we're going to use, Elena regular, Elena bold, Elena italic, and also media bold, right here. And we try to load them all at once with a promise. And once it happens, we display the content in that web font, right? So you actually minimize the amount of shifts that are going to happen on your page as a result of this, right? That's actually pretty cool. But it still doesn't solve this problem, right? Because we have the shifts happening. And ideally, we would like to avoid the situation that we see on the left and replace it with something that we see on the right. It just doesn't play. How convenient that is, right? So here, whenever we see some font maybe appearing, what we would love to see is just no shifts at all. So whenever fonts are changing, it should be really static and calm. So we can, luckily, do this today as well. Frankly, we spend so much time just trying to play with those things and move things around, and I saw this all the time in my nightmares and dreams. I couldn't see this anymore, right? And when you start looking around, there are a few common things that people do to avoid the shifts from happening. One of them would be, let's just use a render blocking base64 encoded web font, so nothing is going to be visible unless the font comes in. But then you don't have any shift, right? This is here, and this is another story here, right? On site.de, which is a German site, you don't see any layout shifts, right? Because again, this is happening behind the scenes. That's not great. That's not nice. This is not something that we would like to do or would like to have. Now you can actually improve it by matching the fallback font against the web font, or the other way around, depending on how you want to do it. And there are tools for that. One of them is a font style matcher, where you can upload your web font, you can check what fallback font you have, depending on the operating system that you're using, and then just to make sure that vertical spacing, horizontal spacing, the line height, the font size are kind of matching, right? This is what we've been doing quite a lot, ending up with a lot of really strange code, typically like this. This is not nice. I don't want to do this for a living, right? But, it really worked. We actually got to CLS 0 at some point, which was really impressive just by doing these magic numbers. Luckily, we don't have to do this anymore because we now have local overrides. Oh, not local overrides, font overrides, or font metrics overrides. We had a couple. Have size adjust, where you can say the fallback is 1.2 times bigger than the web font, ascent override for ascenders, descent override for descenders, and also line gap override for the line height, right? So in your CSS then, right, to reduce this amount of CLS, what you're going to do is, add those things like size adjust, ascent override, descent override, the line gap override, and you kind of avoid this problem altogether. However, you define then your fallback, right, and the top, the font family L and the fallback, but there is not one fallback, is there? No, there is more, because you have different fallbacks, right? You have different fallbacks on different operating systems. And this is what you can call a font metrics calibration if you really want to optimize to that level, right? Fortunately, there is this little tool called fallback font generator that does all the work for you. So you can actually go ahead and use it right away. So I'm being told I have 1.5 minutes. Could I have 7? It's going to be fun, I promise. Nobody's listening to me. Nobody's listening to me. That's okay. That's okay. That's okay. I have chocolate. I can throw chocolate. Oh, now we're talking. Because I wanted to show some CSS and JavaScript stuff. I didn't want to show only fonts. So, all right, here we go. Anybody? In the back. Please. Oh, this is going to be a challenge. Oh. Maybe close enough. I don't know. I cannot see. All right. Oh, this works. This I can do. Anybody here? All right. This I can see hands somewhere. Who is the furthest away? Oh. Ooh, this is going to be scary. I hope I don't. Okay, maybe. Well, there's two more, just two more. Okay, this is easy. Oh, I can't even do this. Unbelievable. Okay, here we go. Okay, I'll try harder next time, I promise. Right? Okay, so just a few things I want to show. If I may, just 5 more minutes. May I? 5 more minutes? Yes, whew, I got a green light. But this will be a fun one. I really want to show a few things which I think are really, really important. This really brought us to a good result. And that relates to the critical path that we ended up optimizing. And this has been extremely adventurous, I have to say. Now, first of all, we often think that we shouldn't be worried too much about it. After all, we load JavaScript, it's going to be in the cache, and that's it. That's not quite like that. Because sometimes, as it appears, as it happens, network can be faster than the cache. It depends on how many assets you have in the cache. It also depends on how much stuff you want to pull out of the cache, right? This was really, really interesting because cached has a real execution cost for IPC cost, disk access, parsing, compilation, and so on and so forth. So it doesn't come for free. So we started thinking a lot about how to optimize it and how to optimize the critical path. One thing was surprising. First of all, we often talk about critical CSS. Anybody knows what I mean with critical CSS? This is kind of the part of the CSS that's going to be kind of used to display the first visible portion of the page. Maybe 1,000 pixels, maybe 1,200 pixels across all breakpoints. That's something we would plug in the head just to make sure that the browser gets everything in CSS to start render immediately. That would be great. In theory, it works. In practice, it's kind of difficult to maintain. You have to do it on different per route or per template. That's really, really difficult to maintain. But if you can do that, it really does work. In our case, it actually did work. So this is what we ended up doing in our CSS. So we inlined the critical part per template. We have only 6 or 7, 6 at this point. Then we have the article. Then we have H1. We have the end of the article. And then we plug in this, which is the style sheet for non-critical article. We call them by names, by cats' names. Don't judge me. Right? We call them Felix, and we have Garfield as well. It's fun. We have really interesting conversations in the company. So we have this non-critical article, Felix, and it has media print, so it's going to get the lowest priority when loading. And we're swapping it from print to all, or to media, right, at this point, once it's done. So that means we'll load everything with the critical CSS alone, right? And then it's only later when actually this non-critical part comes in. Typical technique that many of you might be using as well. And then comes the part here. This is a very common thing that many people do, but it creates one issue that we ended up having. Sometimes this non-critical part would come too early, or it would come too late. So as it turned out, you don't need to necessarily use this print hack, because it's actually quite common, but instead just put this thing, this non-critical part, in the footer. It actually works even better. Right? So, however, this requires splitting into critical and non-critical part. That's one part of the story, though. We also need to think about some others, like critical path for JavaScript. And one thing that was really surprising was this article that I found by Harry Roberts when he was writing, or he's written, about CSS and network performance. And he wrote specifically one thing that really surprised me. He said, define both synchronous and asynchronous JavaScript before your CSS. And I thought, hold on. Why? I mean, don't I want the CSS to come in as fast as possible, and then, JavaScript stuff? Actually, it appears that it's probably not ideal. In fact, when you think about the optimal way of how to define the head in terms of performance, this is what it would be. I highly encourage you to take photos of this. I seriously do. It's from Harry Roberts. It's not really mine, right? But this works like magic. It really does. So you define your meta tag. You define the title, you define your pre-connects, then you define your asynchronous scripts, then you define any CSS that includes at imports. Hopefully there are not going to be any, right? Then you include synchronous JavaScript, reference to just your synchronous JavaScript, and then reference to your synchronous CSS, and then preload, and then the deferred scripts, and then everything else, right? This really does help. Now let's take a look for a moment what it looks like in our case. Now, this is now on smashing, and please pay attention to what happens in the timeline. There will be tests and quizzes later. So this is the loading on a 3G connection, right? Can you see this gap where nothing seems to be happening? Isn't that a bit weird? Why would you do that? What's going on there, right? Well, we obviously, when we look into how this is actually done, we prioritize the critical CSS part, we prioritize some critical JavaScript part, then we do nothing for a while, and then we'll load everything else. What? What is going on here? Well, when we look actually in detail, we actually explicitly delaying JavaScript. We're explicitly delaying things that are not important, deprioritizing them, right? And this works via a delay attribute, pretty much like, this. Where we have this timeout on the top, we have like 5 seconds, could be 3 seconds, could be 2 seconds, whatever it is that you prefer, when nothing is supposed to happen. The goal being, we want to create a clear and kind of really the clearest critical path where the most important CSS and the most important JavaScript are going to be loaded first, right? And only then everything else comes later, right? This could be things that we need for maybe search, that we need maybe for chat or whatever else, right? So we're explicitly delaying JavaScript. What happens here specifically is, we're listening if there are any key down, mouse move, and so events, right? And then we trigger scripts by replacing script delay with actual source, right? After a timeout, or if one of those events happens. Now, this might seem like a very strange thing to do, right? Well, let's take a look at the results, and then I'm done, I promise, right? The results were actually quite surprising. What we ended up with is this, right? So we started off with all Ember, right? Basically, and improving things over time with things like font loading and other things. And as a result, we got to the point where we actually felt quite comfortable. Right? And I'm not trying to show off here. It was actually a really hard journey to get there. I created a list of all the things that we have done for you as well to use at this point. But what's really interesting about this, there is a correlation, of course, between Lighthouse and what you get to see in this kind of here. But the most important things were these ones. And this is, hold on, let me just show this here. Hold on, just a second. Here we go, these ones, which really did help massively. So that means we define the priority where we say we're subsetting everything, CSS, JavaScript, and fonts. We had lazy loading for async decoding to images. We also lazy load third-party embeds with so-called facades, where we show an image first, and then when you operate and interact with it, it's only then when we're loading the script. We move some third parties to a web worker with Partytown, which is a really great tool I highly recommend you to test. We use predictive prefetching, so when somebody is hovering over an article, it's going to be prefetched ahead of time. We replaced all images with AVIF, right? We use resource hints, priority hints, and early hints. And we also optimized a lot that head order to really make sure that everything is ordered the way it should be. And in the end, trying to make sure that we are kind of hydrating partially instead of going all the way, right? And you will find all of this and way more in just this little doc that I compiled for you as well. So it's smash.by/perf strategy, right? Okay, I think at this point I should be done, except just showing, we can do so incredible things on the web. We really could. Because this, for example, is the best website ever because it has the most annoying pop-up in the world. Look at this pop-up. It's so annoying. I love it. I wish it was on every single website out there, right? Or, these things, and they're really easy in terms of performance as well. You're being asked, how old are you? Right? Turn it into a journey, right? You come to Austin Beer Works, you're being asked, how old are you? Let's have a conversation, shall we? Right? And that's easy to do. You don't need to be a performance expert or anything to do that. Just a couple of pop-ups. There is nothing wrong with pop-ups. They can be nice as well, right? It just keeps going and going and going. It's kind of a full conversation going on here, right? Which is actually pretty neat. And eventually, there is no way to click yes. So off you go to your journey into the world of passion, I guess, here. Because when you do click on no, you're going to have a conversation with a friend, right? Or even this, look at this, like the most boring thing in the world. What can be more boring than title? Nothing. Make it interesting. Who would you like to be today? Do you have any preferences? Would you like to be a lieutenant commander, a princess, a professor, whatever you need? There are 54 options here to choose from. Just go for it. This is easy to do. And this, just make people smile every now and again. They start typing and we often think, don't make people think. Make people think! Just every now and again to make them smile, to make them connect with you in some way or the other. I spent, I don't know how much time on this. Right? You probably have seen this. And look at how respectful this guy is. Right? Incredible. But you can pick. That's nice. That's unbelievable, right? And you know the other thing is, there is no harm in making people wait a little. Just make them wait a little. Or even this. Look at that. What's more boring than a toggle? Well, you know that toggle when you have to sign up for something like a newsletter and people sign up and this is it. You know, make them work for it. Make them click 20 times to subscribe. They will remember this for sure, right? That's again not that hard to do. You really want to subscribe? Well, then okay, then here we go. Now you're subscribed, I guess, right? So we can do all of those things, and they're just fun. I love fun on the web, and I think that we should be doing that, and we should be loving the web more. And even if you like jQuery, or if you don't like jQuery, that's okay, because you can still create this with or without jQuery. It doesn't matter. With this in mind, thank you so much for being here. I have cats and more cats and meow, and thank you so much for listening.